I'm always on the lookout for Dr. Romano. Maybe he's over here again. I need some help with stereochemistry. Maybe he's working on some. Hi, Dr. Romano.
Hi, how are you? Come on in.
I need some help with stereochemistry.
Come on over. I got actually three good problems I want you to take a quick look at.
Is this stereochemistry?
Yes. Now, if you look at the first example, I give you something like this. And I want to know, is this optically active? Your best bet, if you ever see a ring, is to remember going up means a wedge and going down means a dash. So I'm going to rewrite this. So this is a wedge going up. This is up. So it's a wedge, and these are going down. It's a dash and a dash. Now, if you put a single dot in the middle here, you can see that this dot is equidistant from this point to this point to this point and to this point, and these are going in opposite directions. In other words, this is going up, this is going down, this is going down, this is going up, and therefore it doesn't have a plane of symmetry, but we call it a center of symmetry, and that makes it optically inactive. So be careful if you ever see a compound with a center of symmetry. Usually a plane of symmetry is a lot easier to spot. Let's go to problem number 2. In a problem, again, when you have a ring, is let's redraw it. That you have this OH going up, this OH is going down, and of course these just mean H's. So what I did, again, on the left side it goes up, OH is a wedge, down, it's a dash. Now, let's go to carbon number 1, and this carbon here is this carbon here. So what do I see coming off it? I have an OH going up, the invisible group is an H, and I put that there. This path goes this way, I'll call that R2, and this path goes up, I'll call that R1. The OH has the highest priority. Group number 4, of course, will be the H. This path is a carbon going to an OH, and this is a carbon that's on a branch that's going down. So this group would have greater priority. So this path would be greater than this path in priority. So you're coming around, connecting 1 to 2, jumping over 4, and that would be an S. So I go back and say that's an S. Now we go to carbon number 2. You have an OH, there's the dash, the invisible guy is an H, the path going up, I'll call that R2. To the left of me, arbitrarily, I'll call R1. OH is group number 1. Number 4, of course, is the H. This path would be 2. This path would be 3. It looks like an R, but because you have a wedge on number 4, you switch whatever you think the answer is. So it's an S. So both of these would be SS.
Wow, that's a lot going on there, Dr. Romano.
And the final one, which I get a lot of questions on, hopefully this will settle it. If I ever gave you a Newman, what you want to do to get the R and the S off a Newman is convert it to a Fisher. So watch the trick. This is my front. So what I do is I cut my first cross. And at the top of the cross is an OH. To the left of me is an H. To the right of me is a methyl. The back ball represents this part of the molecule. And the trick is to swap the two groups on the side. So instead of the methyl being on the right and the hydrogen being on the left, I swap it. The methyl is on the left, hydrogen is on the right, and the bromine stays put. Now, once we got it into this point, watch what I do. I cover this up. The OH group is number 1. This group down here, if I take my hand away, is a carbon with a bromine. That's the two best. So you connect 1 to 2. It looks like an S, but because the H, group number 4, again, is on the horizontal, you reverse your thoughts. So that means this would be an R. So the carbon with the OH, which is here, is an R. Then you go to here. Bromine's number 1. The group that I'm covering up is number 2. This is 3, and this is 4. It looks like an S, but because 4 is on the horizontal, it's an R. I have many, many other videos on this where I do this a lot slower as well as in the Destroyer. But at any rate, this is an RR. And also, if you wanted to see how you convert this into a horse, or a sawhorse, all you do is look at the front. As you can see from here, there's the front. It's got the same groups, the OH up, H to the left, methyl to the right, and then the back hopefully you can see the bromine's down, H is to the left, and to the right is a methyl. So if anybody ever gives you a sawhorse, what I would do is convert the sawhorse into a quick Newman, and then a Newman into a Fisher. I hope this helps on something that I see none of the authors really address. Even the David Klein book, he's a little quick on this. If you understand this, you got it. All right, I hope that helps and gives you a good idea on what to do.
It does, Dr. Romano. Will you be out here again today?
I will. Good day to you.
What will you be working on?
I never know what I do. I do everything impromptu. I'm my own in-house organic chemist, the one in my damn head. Good night to you.
Okay, Dr. Romano. Good day to you, sir. Hope to see you again.